Alright, welcome everyone, it's Fury here. Here's the video about AI Fury. So let's get right into this. So first of all, I'm gonna show you how AI Fury looks like at the moment. What is new, what new features it has and stuff, and then we're gonna start building some simple behavior tree and then complicate it over the time. So you have now possibility of creating multiple, trees, multiple tabs in here. So it's pretty cool for designing purposes. Obviously save and open trees doesn't matter. Now the workspace is way bigger than before, and second thing is that the root node where the entire tree starts is now portable, it's movable, so it's not just like before it was in one place like here or something. You can move it around, which is pretty cool. You have this outer open list, which is pretty cool. Yeah, node properties. For some nodes you can change properties. Obviously you can add description. You can change panel color, which is for now not really. I made it reset when every time I click there's a few bugs here and there, but most of them are relatively simple, so I'm gonna be able to fix them in the end. I'm gonna leave them for the end, the easy bug stuff. So yeah, you can change the even link colors too, which is not really. It's mostly like for designing purposes, done for the technical stuff, right? So also alpha if you want to have, obviously. However, you have obviously new. Yeah. Okay. So let's maybe. Okay. Yes. One more thing. Blackboard. For those who is familiar with the behavior trees at any point, they probably know what Blackboard is. So these are Blackboard keys variables. These are variables that you can create, change their names, assign names to them, obviously, and use them within the behavior tree later. What is very cool about this version of AI Fury is that it's compatible with the flow graph and each leaf node, which is the functionality node. These are composite nodes, and this is functionality node, which is like this will define exact thing that will be happening inside of the engine. And obviously you can load up another tree if you want to have separated tree, put them together by adding tree, and it's also working very well. So let's start building some simple behavior. Let's do for now. Let's make our AI randomly patrolling. He's not gonna be interacting with the player just yet, but let's put it a little bit more in the middle, like this maybe. So he's not gonna be interacting with the player at any point. He's gonna be just able to. He's gonna be randomly patrolling within some radius. So let's do it. Let's do a maybe sequence, I guess. Yeah, let's do sequence. Let's call it main sequence. Let's track out from this, and now leaf nodes. Leaf nodes are created in a flow graph. At the moment, we're just gonna be typing their names. In the future, you're gonna have a list of them. However, let's do walk to location. So this node will be forcing our AI to walk to specified location. Here we're gonna put find random location. But you could say that finding random location and then walking to this location is fine, but not. We have to first of all check if he's already walking to location. Because if he is walking to location, then we should not find another random, because this is called on every frame. So if you randomize location at every frame, he's gonna be standing in one place without any movement, because he will be Pathfinder component in C++ will be very confused. So we have to check if he's not walking, then we can fire this. Let's do maybe leaf that is called is walking to location. but we want to check if he's not walking to location. So in this case, we're gonna do inverter, which is just inverting. If this returns true, then it's gonna be false, and if it returns false, then it's gonna be true. Pretty simple. So if is not walking to location, this is just information for myself, but within the leaf, these descriptions are case sensitive and they are going to be used in the flow graph. So let's put it this way. Okay, let's do some patrolling stuff. I'm gonna save this in here. Yeah, let's do tutorial tree. Okay, let's save it. Right, so now I'm gonna open up another screen for you so you can have a quick overview over this behavior tree at any time. So now we're gonna run the editor and create those leaf nodes in a flow graph, purely in the flow graph, without absolutely any C++ or any other coding. Alright, we've got it loaded in the flow graph, and to create leaf nodes, you gotta go to File, New Module, Global, and then we're gonna go is walking to location, as it says over here, right? It's case sensitive at the moment. I'm planning to change it to make it not case sensitive, but at the moment it is, so let's keep it. Is walking to location. This is important. You have to unlink this, and don't be worried about that. Just put it over there. You won't be using this at any point, because for some reason this is called before my leaf nodes ends, and this just destroys everything. So now our leaf node has to start with leaf task start. You can find it over here in AI Fury. All of my AI Fury nodes will be here, so you can find it over here. Start and end. Each leaf node has to have start node and end node. So for this is walking to location, we want to check if he's walking to location actually. I mean, obviously, but not only. We also wanna grab this AI and actually check if, I mean, okay, anyway, I'm gonna be explaining over the time. But first of all, we're gonna need to create AI Blackboard Key. So maybe let's put it here so it's bigger on the screen. We're gonna create vector, and it's gonna be called move location. Also case sensitive. Save it up. Put it on the other screen here. So now what we gotta do here, we wanna check if he is walking to location. The location is specified within this Blackboard key, so we have to compare AI position to the position that is specified. So let's do get position. Of course, this entity. Let's rename it to, for any people that don't understand this, then let's just put it this way. AI position. Here we're gonna go get, and it's gonna be vector. This is node that is getting our Blackboard key value. So let's do move location. That's how it's called over here. And you can also find it here, all of them. Okay, so what we are doing now is, if we check if the current position of this AI is the same like the position that of the target position that we want it to go to. Let's do equal vector here and here, and tolerance 0.2. This is also my node. It's not. You can find obviously here in equal vector, but what it does, the tolerance, is that the navigation mesh in Cryengine is made out of triangles. So whenever the AI entity goes into some position, it's not always going to be 100% accurate, because this is made of triangles, not of the single points. I mean, I guess that's the reason, but I found that 0.2 tolerance is just perfect. He's just getting almost exactly into the place, so it's not even able, you're not even able to notice this. So now, if these positions are the same, then obviously it means that he's not walking anymore, and it means that he already reached the position. So in this case, I'm gonna make him stop. Whoa, shit, not this one. Oops, I pressed something I wasn't supposed to. Doesn't matter. Okay, let's try it once again, and let's do stop walking. So if these positions are the same, stop walking will make Pathfinder stop the current request. Any. And from this, we're gonna drag out to leave task end, but to the failed. I'm gonna explain it in a while. So if these positions are the same, then stop walking, and if these positions are not the same, then do further check. Is walking, is checking some Pathfinder stuff as well. And here drag out to the condition like this, and then from if it's true, if he is walking, then succeed, and if it's not walking, then false. So either this or that one will fail the leave task. Save it. So second leave task is find random location. In this case, we're gonna also create another flow graph module. Let's do find random location. The same story with this. Also, leave task start, and in this case, find random location. We're gonna randomize current position of this AI around some radius. Within some radius out of his position, and find navigable point. So from here, we're gonna get position of this AI, of course, and then drag out from here and do get random navigable point in radius. This is also made by me. Radius where he's gonna be patrolling, it's gonna be 20 meters. And now this is actually randomizing his position around within the radius, but also he's gonna be it's just I guess considering points that are navigable. However, there is a possibility that your AI would stuck at some point on the map that it is not able to go anywhere. In this case, failed will be called, but we're gonna handle that later. So first of all, with the randomized navigable point is found on the map, then we're gonna go set or Blackboard key set. I'm planning on doing the same thing like is here with these separately, so you're not gonna have to handling that. So move location. This is the Blackboard key. So we're gonna set this Blackboard key to this value. So our new move location will be randomized, vector of the position. And from here, let's do leave task end, success, and if it fails, then fail. Save it. The last one is walk to location. Walk to location. The same story here. Okay, walk to location. Obviously, as always, leave task starts. This is unchanged over entire thing. Here, what we need to do, we're gonna get the get key. Key get, and it was vector key. Move location and walk to location. Leave task and succeeded. Obviously, if you have some more functionality, then you're gonna be handling also fail. Maybe he can't walk to this location, maybe something is on his way. This is all to be done in the flow graph, but for this simple functionality, I think it's enough. So I'm gonna just make sure that move location, okay. So now we can go to our AI. If you don't know what that is, this is the AI character, exactly the same like I made in the last videos for AI Theory. Behavior tree path. We gotta find our behavior tree, which was in scripts tutorial tree. So he's gonna be using this tree. It may crash on the map now because sometimes when I okay, it doesn't seem to crash. So okay, this is just a simple map without anything on it. So let's add spawn point to it, and let's just add AI tutorial. This is our simple AI guy. So let's do now. We have to add AI navigation mesh and navigation area. Doesn't matter how you call it. This is the radius. This is the area where this AI is able to walk around. We need this. So let's save them up and export to engine. And let's see what happens when I run the game. He should be randomly patrolling this entire area within radius of 20. Okay, so you can see he's just gonna be randomly patrolling this area. There is no interaction, that we did not, specify any interaction for him. He's just gonna be randomly walking around within 20 meters or less, because it's also randomized value. So he's just walking around doing nothing. Okay. So he's gonna be walking around like this without the end. Now, what can we do for him? What else would we like to do here? I think we would like to tell him to look at the player, for example. To look at the player when he obviously is able to see the player. If you are behind his back, he's not gonna notice us. But in this case, let's just maybe do. Okay. Let me think a little bit. Okay, let's put some little tree over here, and then we're gonna see what we can do with this. We're gonna need to check if he can see the player. So can see player, and if he can see the player, then we're gonna tell him to look at player. Okay, look at player. In this case, let's maybe do. So if he can see the player, then look at player. Okay, this is gonna be sequence, because you know I think you already know what is difference between sequence and selector. Sequence is called like it's calling the first child. Oh, and it matters where you put it. It's AI Fourier is reading this stuff from left to the right, like this. So if you put it this way, then this is gonna be called first, and this one will be second. So this value is important here. This one doesn't matter, but here. Okay, so what the sequence does is it calls the first child, which is here, and if this child returns true, then it's gonna go to the second child. If this child returns true, then it goes over here to its parent and do whatever is there. But the selector would do fire the first child. If the first child is true, then it's true and it goes further on. But if it's false, then it's gonna jump to the second child and do the same stuff. So that's the difference between them. Okay. Okay, we have this. So let's do player detected. So if the player is detected, then look at the player. But we don't want this at the moment. We don't want this to affect our entire tree here. So it doesn't matter if player is there or it's not. We still wanna patrol the area around. So if you don't want this to affect the tree, you're just gonna pull out from here and do always true. Okay, so it's gonna make it don't affect the rest of the tree. This is just a description, but always true. So no matter what it does, it's always gonna return true. So let's do it here. So it's gonna look at the player and do the stuff. But what is important, we need another Blackboard key. Entity ID, let's call it player inside. So if you can see the player, then it's gonna set this Blackboard key. So now it's always flow graph. And it's here. And another flow graph here. The first one was called can see player. Okay, can see player. As always, drag out, leave, task start, and owner ID. And then let me look at some help of mine. Can see player. There is a node I prepared, which is called can see player. It checks if the player is in front of this AI, if you can actually see him. So now let's do Blackboard key set. Blackboard key set name was player inside. And player value will be this. Okay, so that's it. And now if it's set, the Blackboard key is set, then obviously we're gonna check. Let's check. What it does is actually we're gonna check if the player is actually some valid player. If he can see the player actually. So we're gonna drag out from here and check. Whoops, what am I doing? Oops, no. We're gonna do the check over here. So if A is less than 1, it means it's, player does not exist. He doesn't see the player. So if it's true, leave task end. If it's true, then fail it, and if it's false, then succeeded. So can see player, save up, and another one we have is look at player. Also the same story as always, global look at player. Whoops, like this. Okay, as always, leave, start. You can find, as I don't know if I mentioned, but you can find these over here as well. Okay, in this case, we wanna look at the player. Let me see, where was that? Okay, look at player. In this case, for people who don't know coding, I'm gonna explain a little bit. Okay, first of all, let's just key get. Let's get, entity ID player inside. So we get the player that we are looking at. And now we're gonna check the position. Let's rename it to target player position. And the second thing is we're gonna drag out from here. Whoops. And do get position as well. Whoops, no, this way. Sorry. So this way we get the player position because we get the player inside. In this place we gotta check the AI position. AI position, world position, that's what we're interested in. And then we're gonna do some calculation. Vector 3 calculate and sub. So we do A and B here. What it does, it actually checks the direction. It's some mathematical thing which is not very difficult or any complicated, but you probably know what that is. I'm not trying to, sound smart or anything like this. Just if you subtract target position, the origin from the target position, you're gonna get the direction vector. So look direction. Okay. Look direction in this case. Unlock, leave task and succeed. If you have any more functionality you can do also fail, but let's save all external graphs, see if it actually, okay, let's see if it works. Okay, so he's looking at me now. What I do and where I go. I know you think that he's always looking at me, but it happened that he actually went my direction. That's why he noticed me. If I close it and open up again, he might be going forward, so he's not gonna see me until he rotates in front of me. He's gonna notice me then. So I can see he's not seeing me, but if he goes, I go this way to make him see me. Oh, like this. So now he clamp on me and he's just constantly looking at me. Okay. Cool. What else do we want him to do? Well, I guess he could. What can we do now? Let's maybe do some stuff like the hide points, huh? Let's do it. So if I open up the map now, let's do a little bit of mess in here. Designer tool, let's do boxes like that, like this. It's not really important at all how you put them. It should work well no matter what you do. Okay, just a little bit of walls. So okay, now I'm gonna grab legacy entities, which is my AI hide point that I made also. So I'm gonna, oh sorry, no, one more thing. Before we put any of these, we wanna put a navigation area. You wanna do it this way. And then you go to properties and go exclusion. So this point is excluded from navigation for AI, because as you can see, although these points are excluded, this point is included. So he might end up trying to climb on the top of this, which is obviously impossible unless you implement some climbing system. So we're gonna prevent that. It may be too big, but no. Do exclusion. 1, 2, 3, 4. Exclusion. Okay, I'm not gonna be able to put that so tight over there. So let's grab both of them. Exclusion. So entire thing is excluded from navigation. So now we can safely do hide points. Hide points, we're gonna put them like not too many of them. Just one point on every edge so he can find them wherever they are. Let's do maybe 3 here. One, 2, 3. Whoops, let's maybe not. Oh shit, I removed something from here. So once again, look at player. I'm gonna close the AI Fury application, so okay, let's get back into this. So creating these guys in here, hide points. I can actually hide from me. Well, I guess it's pretty much enough. I'm gonna save them up, export to engine. Okay, and now, so I'm gonna close the editor maybe. Let's open up AI Fury once again. Open our tutorial tree. Where the hell are you? Here, come on. Okay. Okay, so within this tree, we want to actually make him avoid us, or if he see the player, then he should actually find the closest hide point he can and hide in there, and probably wait in there a little bit, but maybe later. So let's do let me think. Okay, so in this case, let's do okay, we've gotta change our tree maybe a little bit. Put it down here, and maybe let's do the main sequence, and maybe do main selector. So let's try out from the main sequence, main selector, and now within the main selector, let's do let's do another sequence. Let's try out sequence. Let's do player detected. Oh yeah, we actually have one here. So let's do this, and let's remove that one. So we have the main selector. Okay, let's grab these away from here. Oh shit, I should be making centering area by within a few days or weeks. So hey, okay, we have the selector here. So here we're gonna do if the player is detected, then do some stuff, and then we're gonna do if the player is not detected. Okay, so if the player is detected, then check if the player is detected actually. If you can see the player, then look at the player, of course. Look at the player. We don't want this to actually affect anything, so let's do always true. Let's also keep it the same name, so it's always true. Look at the player, and then if it's true, then oh shit, yeah, let's do it maybe this way. So if he can see the player, then look at the player, and then let's do leaf. Find the closest hide point. Find the closest hide point. Okay, it's pretty cool, I guess. Now with the blackboard, we need some entity closest hide point. Let's do it this way. So he's gonna find the closest hide point and then go to this hide point. But this hide point will actually set up the move to location value. So here, let's do sequence player not detected. So this is in case if the player is detected. Otherwise, player is not detected. He's gonna be fired, of course. So if the player is not detected, if the player is not detected, and find random location. Whoops, not yet. Not only this, also that one. So the player is not detected, then find, then if not it's not working, then find random location. If he's detected, then he's just gonna find the closest hide point. Okay, and then in the end, if this is either this or this happens, then walk to location. Let's save it up, close it, open up the editor, and see what we can do with this. So as you remember, we already have map prepared for this, which is pretty cool. Find the closest hide point. Alright, so let's open up the flow graph again. Within our modules, we're gonna add a new one. Find the closest hide point. Maybe too long, but okay. And then, as always, leave task start. If you leave task is started, then let's get key get player inside. I should remember player inside. Why we need this is because we want to actually check which player we want to hide from, because you know there can be wall and hide points are everywhere pretty much around the wall, and the player can be on the other side of the wall, and so the AI won't choose the hide point that is on the same side where, you know, it has to find the hide point where he can actually hide from player. Here, okay, get. Oh, but not this one. We wanna key get entity ideas. Well, in this case, it's gonna be closest hide point, and from this one we're gonna drag to math equal check. Yep. And from that one we're gonna drag to find the closest hide point. I'm gonna explain entire flow graph in a while. And now the player that we want to hide from is this player. But first of all, we're gonna call that, and this is gonna call this one. So let's make it. Yeah, let's put it this way. Okay, he gets the closest hide point, and he gets the player that he wants to hide from. So hide from player. So if the closest hide point, the last one, is the same like the current one, then we don't want to, you know, apply anything. But if there is new hide point found, then we're gonna redirect player, change his destination. Oh yeah, and the check is also done over here. So in this case, from the true, I'm gonna drag out to leave task end, and in this case, from the true, he's gonna fail, because if they are the same, then no new hide point found. And if this is false, then success. But also we have to set up some, if they are different, then we have to set up some other shit, like oh shit, why the hell? If they are not the same, then Blackboard Key set. I don't know why they are going that far. Okay, now closest hide point. So we save the new one, so on the next frame we can check if there is new hide point found. I hope you understand and you follow me. I know it might be actually pretty complicated, although this is not programming. Okay, we have that, and closest hide point in this case is the new one. But that's not the only thing that we want to set up. Let's do it this way and true. If they are the same, then sorry, no, I'm actually confused now. Blackboard key set again, but at this point we're gonna move location. That's what we're gonna set up, and move location is here from the closest hide point. You could also get position from the entity if you want, either this or that way, but if I already have this here, so why not use it? Entity ID. Don't worry about these connecting owner ID, because I'm gonna remove that later and all will be together inside this get and set key, so they're gonna have already entity applied. Okay, so we set up move location and we set up this, and I guess we can save it. Hopefully I haven't forgotten about anything, but yeah, save all external graphs. So he finds the closest hide point. I don't know if that's all what I wanted. So I'm pretty tired at that moment. So I've been working on those behavior trees a little bit today, playing around with this. So I created a couple of cool behaviors. I may be doing video out of this. But yeah, he can't see me. So now he noticed me and he's looking for the hide point. He's hidden behind the wall, and from that point he's gonna keep he can't see me anymore, so he's just doing patrolling randomly. As you can see, he's just still looking at the same direction, so we should reset the direction if he doesn't see me. Let's open up behavior tree. Okay. I'm gonna look into my resources. Okay, so here, if player is not detected, we should reset his look direction, because as you remember, here is looking at the player and is still valid over here. So let's just do another leave task and let's call it free look orientation. Save up, and yeah. Free look orientation. And as always, leave task start. Shit. Not this. Leave task start. As always, now we wanna free his orientation, so he's still looking at the direction which he's walking to. Free look orientation. So it's gonna be pretty simple. Let's do look direction. Look direction. And let's keep it 0. This is magic number. He's gonna reset it. Leave task end. Succeeded. We don't need any functionality for it to fail. So let's launch the game and see what happens. He should be now, if he notices me, he should be hiding behind the wall, or in the closest hide point where he can find. Okay, he noticed me right away. He's going behind the wall. So if he reaches that point, he keeps. You can see he keeps. He's like unaware of me anymore. He can't see me anymore, so he's patrolling randomly. If he notices me once again, he's gonna be yeah, that's the closest hide point for him. So because we did not put any cool hide point, he's still looking at me. So now he was able to, as you can see, he's hiding from me. This is the closest hide point for him. I can change his hide point if he could notice me now. Yeah, he's looking for another one. But if I make it invalid, so another one is fucked up, so he can't hide from me anymore. So as you can see, he's still changing it. He changed to the next one. This one is invalid anymore. He changes to the next one. So this is the closest at this point. Cool. We have this hiding guy here. It obviously depends on the map. So if you have better map that you could put these hide points in very cool way, that he could be hide behind some wall in the building, that would look much better than this bullshit that I made. But yeah, it's working. Trust me. What else do we want to do? We want him to actually, if he sees the player, we want him to draw the weapon. And if he doesn't see the player, we want him to hide the weapon. Simple as this. So let's fire off the AI Fury once again. I know this video will be pretty long, but it's worth it. Shit, I've lost it. Holy shit, yeah, I've lost it completely. I should have done some, centering stuff for this, but I haven't done it, and now I'm fucked up. It should be somewhere here, yeah. Okay, as I said, still a few bugs here and there, but the functionality is cool. You're already able to do some pretty complex stuff. Trust me, I did some quite complex stuff with this, and I'm fucking proud of it. So let's make him holster and unholster weapons whenever we want him to. I'm gonna be using the default Crytek weapon, kind of weapon. So okay, so here, if the player is detected, is obviously always true. In this case, let's maybe put it away from here. If you can check it, no, not this way. Maybe we can check it quickly. So the selector. Let's do weapon handler. Let's do that. Doesn't matter. Let's call it weapon handler. Can see the player. If he can see the player, then do this stuff. But if he can't see the player, then if he can't see the player, then just do holster weapon. Alright, holster weapon. In this case, if he can see the player, we should do some other weapon handling like this. Let me think. Okay, this can go into the end. Look at player. And yeah, we can do here. Let's do sequence because I'm gonna do something. The naming can be the same. It's not really a big deal. Let me. Okay, so if now we're gonna check if his weapon shit. So how can I do it? Let's maybe put it down here. So if he has weapon in hands, oops. maybe not. Okay, because I'm preparing this for the next stuff, so I'm gonna put it this way. Weapon drawing, let's call it this way. And let's do, if he has weapon in hands, then do nothing. But if he does not have weapon in hand, so if it fails, then gonna draw, selector will select second child, then draw weapon. This one should belong here. So let's save it and close Ai Fury. Open up this and let's create another stuff. We have, oh shit, I should have done. Okay, doesn't matter. I have these names here, so global, as always. Anyway, let's just do holster weapon. Shit, no. As always, leave task start. It's nothing different. This is gonna be for every single leave task. And now we're gonna see if he actually has weapon in hands. Oh, sorry, not. We're gonna holster weapon. So drag out holster, unholster. So you're gonna do holster weapon and it's done. Leave and succeeded. The second one we've had was has weapons in hands. That's what it was, I guess. As always, leave task start. If leave task is started, then we check is holstered and result condition. Of course, check the condition if he's false. Gonna leave task end, and if true, succeeded, because we want to check if he has weapon in hands. But this is holstered, so if it's holstered, then he doesn't have it in the hands. So that's why it's true is false and false is true. Okay, has weapon in hands. Save. And the last one we have is draw weapon. Leave draw weapon. Draw weapon. We'll do pretty much the same, that holster and holster, but with the draw weapon. So here, leave task end. Leave task end succeeded. Okay. Not sure if this is enough. I don't remember what we did in Ai Fury. I got really short memory. But we'll see. So he notices me, he holds the weapon. As you can see, he's got weapon in the hands now, and animation is also played. So he doesn't see me anymore. If he doesn't see me anymore, he should be... Ooh. Yeah, there's something wrong with my logic. The animation is fucked up because he's changing between having and not having weapon. So I might have done something wrong with the logic of this behavior tree. I'm gonna look into this. Okay, here. Can see player. This should be always false, I guess. Always false. Yeah. I'm not gonna comment it at all. The reason for this is because basically, if this is fire, then this is already false everything, because he can't see the player. It means if this is fire, then he can't see the player. But if it returns true, then it's gonna fire all the other stuff. So he's gonna holster and draw weapon. So to prevent it from happening, that's what we should do. Hope it's pretty simple and obvious, but if you don't get it at the first time, then don't be worried about it, because although it's not programming, it's still really complicated. And yeah, so just as you can see, his weapon is hidden now. If you're gonna notice me, yeah, he took the weapon again, and he holstered the weapon. As you can see, he's looking at me with the weapon. Okay, so we've got this thing. Cool. So now, what we want to do, let's make him shoot at the player, right? So let's just do simple module that will be called fire. Leave task start. Let's do fire. Yeah, Fury fire. Fire ratio, let's do 500. And fired, leave task and succeeded. Cool. Save all external graphs. Open up. Oh, yeah, open up Ai Fury once again, because, okay, now in this case, this is also something we've got to do. The weapon handling, the reason why I did this sequence and selector is because the selector is the one thing here, and the second one for this sequence will be fire. So if he draws the weapon, then he can fire. See what happens now. So as you can see, he's looking at me, and as you can see, these little balls he's firing at me. He's looking for the hide point. Now he holstered the weapon. He's got no weapon anymore. He's patrolling. Now he notices me, starts shooting at me. He's trying to obtain some hide points that are nearby. Can't see me anymore. He's patrolling and shooting at me. So cool. What else do we want to do? Let's maybe, well, damn it. Let's try to make him wait when he finds the hide point. Then let's make him wait like 4 seconds or so. So in this case, the waiting is slightly more complicated. I mean, I found that more complicated. So let's do, first of all, let's do, if he notices player, right? If he sees the player, notices the player, I mean, he should stop waiting. No matter what he does, he should stop waiting. If he obviously he sees the player, so he stop waiting, because that would be stupid if he's still standing at the same point if he sees the player. That would be pretty stupid AI. What else we've got? We gotta go here into walk to location. Let's put it. Oh shit! Let's put it maybe. Damn it! So let's grab this entire tree. Put it aside. Yeah, put it aside like this. And the move locations in the end. So now we should do a few of new nodes. Let's do always true. So it does not affect the rest of the tree. Let's do sequence. Wait sequence. Okay. Put it maybe a little bit right. And now inverter. Of course, as always, if it's not working, to location. Change it into if he can't see the player, so he can wait then. Can see player. So if he cannot see the player, that's why we have inverter. And if he is at height point, then and he is not waiting, because if we apply wait on every frame, he's gonna be waiting forever. So if he's not waiting, let's do leave is waiting, and in the end, let's do leave wait. Also here, an actual waiting will. So let's make an actual waiting to affect inverter. If not waiting, leave is waiting. So if he's not waiting, then walk to location. Can save it up now, and we have few of this here. I'm gonna close it and don't know what happened here. Okay, need to create a few. So is at height point. Shit. Leave task. Drag it out this way. Let me see what we've got. Is at height point. Entity ID. We've gotta get key get entity ID. We're gonna get closest height point. I should remember we had this Blackboard key. Now we're gonna get position. Get position of this. Height point position. Drag out from this. And grab the entity ID. So this is gonna be AI position. So now let's check equal vector. If these vectors are, and as always, we're gonna do 0.2 and leave task, and if it's true, then false. Damn it. leave task end, true and false. So this way he's gonna check if current position is the same as the height point position. It means that he is at the height point. So we return true. If he's not at height point, it's gonna return false. The next module we've got to do is, as you remember, we've had is waiting. If he is waiting. Okay, now this is pretty relatively simple. I mean, condition, maybe too far away. Is waiting condition, leave task end, and it gotta be this way. So if he's waiting, then true, succeed, and if he is not waiting, then fail. Pretty simple. Okay, now we have also got wait. Wait is start waiting. Let's do 4,000 milliseconds, which means 4,000 is 4 seconds. Leave task end, succeeded. Right, okay. He's gonna be waiting this way. And one more, stop waiting. Stop waiting. Stop waiting. It's just as simple as the others. This is implemented in C++ before. So stop waiting. See what he is doing now. I hope we actually added everything that we wanted. Walking around, let's see if he's not waiting at this point. So he notices me as he's still doing this shit. He doesn't see me anymore. Come on, shit, look at me. Why are you going that far? Oh, come on here. Oh, shit. Annoying. So can't see me. Can't see me anymore. I don't know why is he patrolling now. Let's see into our behavior tree. Might be something I forgot about. Okay, let's see. So he's player detected. Weapon handler, I guess. do some quick check in here. So this sequence does not affect the rest of the tree. Let's see what it does now. Because we don't want any of this stuff like firing or holstering, unholstering weapon to be affecting the movement. So in the future we probably want, yes, so that was the reason why he stopped doing this. So he should be going there now and waiting for a few seconds. So if the, it's gone, he's waiting. Yeah, he stopped, he waited for 4 seconds and he's now patrolling randomly. He's like kind of forgotten, he's forgotten about me. So now he's looking for the, so he's waiting. I'm looking through the wall, I know, but it's pretty cool for the testing stuff. So he waited a little bit and he's walking around. So the reason why he did not want to stop patrolling before was, as you can see, so everything works now. I found the closest hide point. I'm gonna change his hide point now. So he notices me. He's looking for another one. I'm not gonna let him. Make him busy. I'll look for another one, guy. Come on. Hide better. Not like this. I can see you there. I can see you there too. Alrighty. That would be pretty much it, because the video is quite long now. That's how my behavior tree looks like. Could be probably a little bit simpler than this. I have to test a little bit more, but it looks quite good at the moment. It works very well. I did a little bit more complex stuff with it, which, as I said, I may do some videos about this. Anyway, the reason why he did not try to find hide point before was because I did not put always true in here. It's because the weapon handling stuff, we don't want these weapon stuff to affect movement. So because without this, if he fails at some point here, it's not gonna go further. He's not gonna find, he's gonna stop on this, return, and then fuck off. He's gonna keep looking for a random location. So we don't want weapons to affect movement. That's why I put always true. But there are multiple ways to achieve this. You can, for example, do separated trees for this, so they don't affect each other, which is pretty cool. And also, you could do. I'm gonna add actually possibility of adding multiple trees to AI, so he can be. You can do like movement tree. Let's say weapon handling tree, and he's gonna be firing them one by one. Alright, so that will be pretty much it for today, and let me know what you think about this new AI Fury version. I think it's pretty cool. So I'm waiting for you to comment this video. See you later.